What if the universe is shrinking, not expanding? Astronomers think galaxies are flying apart, but what if space itself is collapsing and we're too small to notice the walls closing in? The prevailing theory for decades has been that the universe is expanding, driven by a mysterious force called dark energy, which is causing galaxies to drift further and further apart like ships on a limitless ocean. Scientists have observed this expansion remarkably accurately, measuring the redshift of light from distant galaxies, phenomenon where the light stretches towards the red end of the spectrum as it travels through an expanding space. Much like the sound of a siren changes pitch as it moves away from you. However, a growing number of researchers are suggesting that this expansion isn't the whole story, but rather a consequence of a deeper, more unsettling reality that space itself is contracting, and we, along with everything else in the observable universe, are simply too small to notice the walls closing in. Think about it like this, 5D. Imagine you're sitting in a room with a very slow moving wall, and the wall is subtly, almost impossibly slowly getting closer to you with each passing moment. And you have no way of truly detecting the movement because you're so small and contained within the space itself. The evidence for this contraction isn't a dramatic, obvious shift. Instead, it's built upon subtle anomalies in the way galaxies are moving relative to each other and the behavior of the cosmic microwave background radiation, the afterglow of the Big Bang, which should be stretched along with the expanding universe. Instead, some analysis of this background radiation suggests a preferred spatial scale, a kind of graininess that hints at a universe that is not uniformly expanding, but rather influenced by forces that are pushing it inwards, creating pockets of expansion and contraction. The mathematics involved is incredibly complex, involving general relativity, Einstein's theory of gravity, and sophisticated computer simulations designed to model the evolution of the universe over billions of years. These simulations, when run with altered assumptions about the universe's overall geometry, often produce results that align much more closely with observations of galaxy clusters and the distribution of matter in the cosmos. It's crucial to understand that this doesn't necessarily mean the Big Bang was a complete lie. The initial expansion is still a fundamental part of the story, but the subsequent evolution of the universe might be driven by a different and far more mysterious force. Dark energy, the force that's supposedly responsible for this expansion, might not be a constant uniform pressure, but rather a localized effect influenced by these inward pulling forces, acting like a kind of cosmic tension trying to compress space itself. Consider the concept of a rubber sheet free. If you draw a circle on it, the circle will expand as you stretch the sheet. But if you were an incredibly tiny ant living on that sheet, you might notice that the sheet is also subtly warping and twisting around you, creating a complex interplay of expansion and contraction. The implications of a contracting universe are profound, suggesting that the universe's age isn't infinite, and that eventually everything will converge towards a single point, a theoretical singularity, a moment of ultimate density and heat. If space is contracting, then the distances between galaxies won't just increase, they'll actually start to decrease, and the rate of that decrease could accelerate as the contraction intensifies. This isn't simply a theoretical puzzle, it has direct consequences for our understanding of the ultimate fate of the universe, potentially leading to scenarios vastly different from the current predictions of heat death and eternal expansion. Scientists are actively searching for evidence to support this idea, looking for subtle distortions in the distribution of galaxies, anomalies in the cosmic microwave background, and potentially gravitational waves that could carry information about the universe's internal dynamics. The search for these clues involves incredibly powerful telescopes like the James Webb Space Telescope, which can peer back to the earliest moments of the universe, and sophisticated computer models that can simulate the complex interactions of gravity and dark energy over cosmic timescales. It's worth noting that the idea of a contracting universe doesn't necessarily negate the concept of dark matter, which is thought to be responsible for the gravitational effects that hold galaxies together, but rather it suggests that dark matter might be playing a more active role in shaping the universe's evolution. Furthermore, this scenario challenges our fundamental assumptions about time itself, suggesting that time might not be flowing in a linear fashion, but rather that the past, present, and future are all intertwined in a complex, dynamic interplay influenced by this collapsing space. The notion of a shrinking universe forces us to reconsider our place in the cosmos, transforming us from observers of an eternally expanding universe to potentially tiny inhabitants caught in a cosmic squeeze, a slow, inexorable descent towards a singular point. Imagine the feeling of being trapped within a tightening shell with no outward escape, a sensation of increasing pressure and confinement, a profound sense of urgency as the walls draw ever closer with each passing moment. The pursuit of answers to these questions is driving innovation in astrophysics, leading to the development of new observational techniques and theoretical models, pushing the boundaries of our understanding of the universe and our own existence within it. Ultimately, the possibility of a contracting universe reminds us that our current understanding of the cosmos is likely incomplete and that the greatest discoveries often lie hidden in the most unexpected corners of the scientific landscape, waiting to be unearthed by inquisitive minds and persistent exploration. So, next time you look up at the stars, consider the possibility that you're not just seeing a universe expanding outwards, but a universe subtly, relentlessly shrinking in on itself. A breathtaking and unsettling thought that forces us to confront the deepest mysteries of space, time, and our place within the grand cosmic drama.